why are we comparing the 5060 Ti 16GB up against the RTX 4070? Nobody on a 4070 is thinking about upgrading to 5060 Ti, or well, if you are, hold off on whether that's even an upgrade. As you can see here, the 4070 is usually faster in raw power. However, the 50 series does get multi-frame gen support, and the 16GB version of the 5060 Ti does have more VRAM than the 4070, but I don't think it's at all worth upgrading or side grading or whatever you want to call it from the 4070. However, if you're somebody who's thinking about buying a graphics card right now, these cards may be in direct competition. The 4070 has been recently listed new at $550 and then kind of went out of stock new, and then used prices are still hanging out in that ballpark. Now, how about the 5060 Ti 16GB? And again, I can't emphasize enough, 16GB version. I do not recommend buying the 8GB version for its inflated prices. Now, the 16GB version is also expensive right now. It's $500 if you're looking for something that's in stock new right now, up to about $550, and most models are sold out. That is well above the MSRP it was listed at, but that does again put it up in direct competition against the 4070. And honestly, the used market right now is where a lot of the value is in the PC market. I highly recommend checking out Jawa.gg to buy, sell, and upgrade your PC hardware between gamers. Not only that, I can save you $10 off your first purchase using code OWEN10, and a huge thanks to Jawa for sponsoring today's video. In addition to searching for individual parts like the RTX 4070, you could even find a perfect PC with the exact budget you're looking for, the exact parts that you're looking for, or even the theme you're looking for, because for a lot of gamers, the PC itself can be a focal point of the room, so you can get the style you're looking for. There's all sorts of rare finds, and the silver lining to PC components, especially graphics cards being expensive right now, is selling your old hardware carries more value, which means you can then use that value to fund your upgrade. Jawa offers two options for this. They'll buy CPUs and GPUs directly, instant offer, super convenient. However, you can also make your own listings, even make a business out of being a Jawa seller for individual parts or PCs, whichever way you prefer. Both work amazingly well. There's a ton of great reviews. And there's even a Discord server where you can get one-on-one feedback. Anyway, again, use code OWEN10 for $10 off your first purchase. Follow the link in the video description and or pinned comment. So again, we're looking at these cards up against each other because somebody buying a card in the $500 price range might very well be considering a used 4070 up against a new 5060 Ti. Like I said, the biggest differences here are really in the feature set and the VRAM. So let's actually rewind this for a second and take another look. So this is looking at all of the Nvidia features. We're looking at path tracing, we're looking at frame generation, we're looking at the DLSS 4 upscaler with the transformer model, ray reconstruction, all of that. So if you're using all the Nvidia stuff, how do these stack up? Well, they both support frame gen ×2 mode, and when doing, and by the way, I think I forgot to type it in here, but this is 1440p, but then DLSS balanced using the new transformer model, ray reconstruction on, and frame gen on. If they're both using the ×2 frame gen mode, so apples to apples comparison, the 4070 outputs 19% more frames. However, it's only 89 versus 75, and remember that's ×2 frame gen. The actual responsiveness, like the input latency, is only gonna feel like about half of that. Notice our latency numbers are around 60-ish milliseconds on the 5060 Ti, but they're lower, maybe 50-ish milliseconds at the same time as I was saying 60 milliseconds on the 4070. So it is more responsive. Now that being said, let me go back one more time, and the 5060 Ti can offer a ×4 frame gen mode. So it's essentially just inserting more generated frames in between the two rendered frames. Again, notice that latency-wise, this does not improve things. It makes things slightly worse than the ×2 frame gen mode, just because there's a bit more computational overhead involved. So this is not making the game feel anything like 120-something FPS. It looks like it averages 133 at the end of the benchmark run. However, it does mean you see more frames on your display. So in a single player game where input latency is not the end all and be all like a competitive game, frame generation can be a nice feature to smooth out the motion fluidity of the display, but it isn't making the game more performant. So I don't think it's fair to weight it as raw performance on like a bar graph or anything like that. But it is a nice to have feature if you have a high enough base frame rate. The problem that we're seeing in this particular test is the base frame rates aren't super high. What we're looking at now is the same test with frame generation turned off. So with 1440p RT overdrive, DLSS 4 transformer model, balance settings, ray reconstruction on, but no frame generation, the 5060 Ti is only averaging 44 FPS. And the 4070 is actually only averaging 51. So really what we're seeing here is neither of these GPUs are particularly good for path tracing. Like I said, even with balanced mode DLSS and ray reconstruction, we're not getting a 60 FPS average here. Now, the closer your base frame rate gets to 60, the better frame gen kind of works. So there is that. But again, it's just not an amazing experience here on either one. So I would say that if you're buying Nvidia GPUs for the big path tracing experience, I don't think either of these GPUs are going to deliver an amazing 1440p path tracing experience, although it will be passable with frame gen for people who aren't particularly input latency sensitive. But there's a whole other type of gamer out there, and that's the ones who spend most of their time playing competitive, like esports type games, competitive multiplayer games. And we're looking at Call of Duty Black Ops 6 here, 1440p resolution, but at basic graphic settings, because we're turning down graphic settings to get a competitive edge in both frame rate and decluttering the environment. And what we're seeing here is that this wouldn't make sense to turn on frame gen. Also look at the latency numbers here. We're talking like low to mid teens in the milliseconds here. A lot more responsive than the 130 FPS we saw using ×4 frame gen in the last test, right? Anyway, here we're seeing the 4070 hits 165 FPS versus 140 on the 5060 Ti. They're both doing a good job, but the 4070 is 18% faster, and I don't think any of the new feature set advantages make any sense there. That being said, I do think DLSS makes sense in competitive games, just not frame generation. Remember that unfortunately NVIDIA's kind of complicated DLSS as listing two completely different technologies that have different use cases under the same DLSS branding. DLSS upscaling, which I'm using here, boosts performance and responsiveness by decreasing the internal rendering resolution. So the game literally does render faster, and then it just tries to reconstruct what a 1440p image would really look like here. So notice the 4070 is now running 213 FPS versus the 5060 Ti at 183. So the 4070 is still 16% faster. They're both getting good frame rates. And again, latency numbers are even a few milliseconds lower than what we saw with DLSS turned off. So good stuff. In this kind of situation, there's really no reason to think about the 5060 Ti over the 4070. At low graphic settings, or even if you're playing at 1080p resolution like we're seeing here, 1080p basic settings, esports games at low settings, at high frame rates, 12 gigabytes of VRAM is absolutely fine, and multi-frame generation is not helpful to you. That's what we're getting out of this. And the 4070 has more raw power. So if that's where you're leaning into things, your playstyle, I think the 4070, if these are similarly priced, may actually be the way to go. However, we got some more games to test out here. So here we're looking at Final Fantasy 16 and 1440p Ultra settings. Here we're actually seeing the raw performance numbers pretty close on both GPUs. The 4070 is winning by 4% at 52 FPS versus 50. Notice here that the raw power kind of advantage for the 4070 isn't as pronounced as we saw in our other tests we've looked at so far. But that's just how it is sometimes. If we go ahead and kick on DLSS quality, which I think a lot of people would do since we were below 60 FPS, even a single player title here, we now see that the 5060 Ti takes a small lead by 3%, but again, it's 74 FPS versus 72. I think the best way to class this game's results is that these are essentially tied in performance in this game. And they're both giving you a decent experience once you kick on DLSS quality at the ultra settings for a single player title. If you're thinking about 1080p resolution, I tested that as well. It's 75 FPS versus 73, this time advantage 4070 by 3%. But again, Final Fantasy 16 is pretty much a tie between the two GPUs. Now, if we go to Ghost of Tsushima, at 1440p very high settings, I'm actually noticing the 4070 up by 24%. Not only that, I noticed that my 5060 Ti has some graphical corruption, which you'll see most pronounced as we come up over this hill. You'll see some fire kind of right here, and you'll notice it kind of flickering all weird on the 5060 Ti. Now, this was tested on the review drivers. Recently, there's been some driver hotfixes from Nvidia, and Ghost of Tsushima was called out as having some fixes, so it's possible that that corruption has been fixed since my recording here, but I have not been able to go back around and retest to confirm that. But it was listed in a driver hotfix, so throwing that out there. At 1080p very high settings, the 4070 is winning by 22% at 109 versus 89. Again, I see the graphical corruption issues, but once again, it's possible that that has been fixed by Nvidia. It is noted that this game has some graphical corruption fixes in their hotfix drivers. Taking a look at God of War Ragnarok at 1440p Ultra, both GPUs do well. 73 FPS versus 66. This time the 4070 is taking an 11% lead in both the averages and the 1% lows. So good result on both. Again, you could turn down graphic settings or use DLSS if you want better frame rates. I chose to test out DLSS, so DLSS quality here. Again, no frame generation. We're just increasing the performance through changing the internal rendering resolution. We're seeing 93 FPS versus 87. So now the 4070 is 7% faster. Again, note that you could use frame generation on top of this if you want even more motion fluidity, but again, not increased responsiveness. At 1080p Ultra settings, we're seeing the 4070 take a 6% lead at 89 versus 84. So again, it's fairly close results, but the 4070 is a little bit faster. Good experience on both GPUs. Let's check out an Unreal Engine 5 game. Here we're looking at Silent Hill 2, 1440p epic settings with hardware lumen turned on, so hardware ray tracing being used here. And you can see that neither GPU is really good at maxing out super heavy Unreal Engine 5 games at 1440p. 45 FPS versus 41. This is a slow-paced game, so it's playable, but I think it would make sense to at least turn on DLSS quality or turn down game settings. Here I tested out using DLSS quality, again, no frame generation, and both GPUs are now hitting 65 FPS, so it's a tie in the averages, small difference in the 1% lows, but again, these GPUs are basically tied here, and they are averaging over 60 FPS now at max settings, but using DLSS quality at 1440p. If you're playing at 1080p resolution, they can both get around 60 FPS with no upscaling at 63 versus 60, so a 5% lead for the RTX 4070 here. Again, you're basically getting the same experience. Another Unreal Engine 5 showcase is Hellblade 2 Senua's Saga. This time the high settings are as high as it goes. There's nothing above this, and there's also no hardware accelerated ray tracing lumen available in this title. Here we're looking at 51 FPS versus 49, so again, pretty much the same performance. 4070 is technically winning by 4%. If we go ahead and use DLSS, performance goes up to 78 and 77. Now the 5060 Ti is 1% ahead, but again, it's basically a tie. They're giving you a very similar experience. If we go to 1080p high, we see the 4070 winning by 1 FPS and 1% at 72 versus 71. So again, good experience on both, and it's basically the same experience. Now, if we go ahead and test out Horizon Forbidden West, I now see the 4070 taking a 19% lead at 76 versus 64. So good experience on both, but definitely noticeably better on the 4070. And if we drop down to 1080p very high settings, which again is the highest settings available in this game, we're seeing the 4070 take a 17% lead at 104 versus 89. And that, wait, one more game I tested, forgot about it. Indiana Jones and the Great Circle. And I'm testing out its max non-path tracing settings. So these are called Supreme. At 1440p Supreme, the 4070 is good for 85 FPS, the 5060 Ti is good for 77. So the 4070 is 10% faster. Not like incredibly noticeable lead, but it is a lead by 10% for the 4070. And if we drop down to 1080p Supreme settings, the 4070 is 9% faster at 108 versus 99. So I think that is now all the tests that I ran, and we could summarize them like this. So this chart is showing in each test what the percentage difference was. Now, the 5060 Ti got a couple of wins, but I have chosen to express these as positive numbers are indicating the 4070 advantage. So what I've done is I've taken the percentage advantage, and if the 4070 has a percentage advantage, I've represented it as a positive value here. The negative values are just the percentage advantage if the 5060 Ti 16GB had the advantage. So here, for example, in Final Fantasy 16 1440p Ultra DLSS quality, the -3 indicates the 5060 Ti had a 3% lead. Not 3% slower, not saying the 4070 was 3% slower, this is the percentage advantage. I've just assigned a negative value to the 5060 Ti to split it that way. So as you can see here, there's only a couple spots where the 5060 Ti has a lead. There's another one where it's basically a tie, and in general, the 4070 is averaging faster. The geo-mean of all of these results is that the 4070 is about 10% faster on average, but you can see really it ranges from basically tied to over 20% faster, with the average result coming out at around 10%. Here's another way of sorting the data. So here we've sorted it as best result advantage for the 4070 on top, and then it drops down to best advantage for the 5060 Ti, worst result for the 5070. So if you look at it this way, again, another way of visualizing the data. In general, though, it's very clear that if all you're interested in is the raw performance, the 4070 is better, although not by a mind-blowing margin. However, in certain games, it is a 20% or more advantage. So there are some individual games where it is pretty noticeable, even though the average is only about 10%. And notably, there is no games, at least in my testing, where the 5060 Ti had a particularly noticeable advantage. Its best advantage was effectively a tie at 3%. So if you're just looking at raw power, I would say the 4070 is definitely the better choice. But again, as I was saying during the side-by-sides, there's more to it than raw power. The 5060 Ti does have more VRAM, and I probably could have cherry-picked certain games that do go over 12 gigabytes of VRAM at certain settings, and I could have showcased that here. So if you are using settings that go beyond 12 gigabytes of VRAM, the 16 gigabytes will perform better at those settings. It's just that right now, at 1440p and below, there are very few games that do push beyond a 12 gigabyte borderline, and usually tweaking one or two reasonable settings gets things in line. Now, if you're going to hold on to this graphics card for 5 years plus, that's where the 16 gigabytes of VRAM is likely going to pay off. We've always seen that, if you hold onto your card for a long time, having that extra VRAM really starts to show its worth the further and further you go. So 12 gigabytes is fine at 1440p right now, outside of a few outlier cases that are easily fixed with a few settings tweaks. I think as we start to get into the next console generation, we're talking the PS6 type generation, I think that if that comes with more RAM than the PS5, which is highly likely, we've always seen that be the case with console generations, then with consoles being the development platform target, I think that's when we'll start seeing an increase in the VRAM target for the core visual design of the game. Of course, I'm sure that there will be settings that scale down below that. And that's where I would probably anticipate 12 gigabytes maybe starting to be a little more borderline if I'm trying to look in a crystal ball, which is never going to be perfect. Now, the other thing, like I said, is if we can go back to what we mentioned at the beginning, the difference in feature set for frame generation, having the ×4 frame generation. So how much is that worth it? Well, Like I said, in competitive games, it's not worth it. It actually decreases your input responsiveness because it has to buffer a frame slightly longer to do the frame generation, as opposed to if you just weren't doing that. So ×4 frame gen, multi-frame gen isn't really useful in competitive games. In single player games, it's only useful if your monitor refresh rate is really high. The reason I'm bringing this up is the 4070 already has a ×2 frame gen mode. So think about it like this. Generated frames don't increase your responsiveness, which is the only real advantage to running games above your monitor's max hertz, right? Your max refresh rate for your monitor. In competitive games, you can sometimes still get a responsiveness advantage. Whereas in a single player game, you just get screen tearing and such, so you would cap or VSync lock below your monitor's max refresh rate, which means there's no reason to use multi-frame generation or frame generation in general to go above your monitor's max refresh rate. And since frame generation for most people kind of feels good from at least a 60 FPS-ish baseline, some people are tolerant below that, even to 50 or 40 FPS. But I think for a lot of people, 60 FPS and then you kick on frame gen is where it feels pretty good. Realize that ×2 is then getting you to around 100 to 120 FPS of motion fluidity. And that's where a lot of people's monitors cap out. Maybe 120, 144 hertz, 1440p display isn't too uncommon. If that's where your monitor caps out, then the ×2 frame gen mode already gets you there, and the ×4 frame gen mode doesn't really now double your performance beyond that, if you think if you think about it that way. Now, if you have a 240 hertz monitor, that's where a ×4 frame gen mode might be more useful, because now you can take 60 up to beyond 200. There's a little bit of overhead there, but that roughly into the 200 plus FPS region. And that does increase the motion fluidity, not the responsiveness, but it continues to increase the motion fluidity. So that's something to think about there, is you already get the ×2 on the 4070. So the ×4 is really just if you have a really high refresh rate monitor. I think it makes sense on like 200 hertz plus, maybe 180 hertz plus displays, but really it's just getting you a little bit more motion fluidity compared to the ×2 frame gen mode. It's not making bad experiences good, because frame gen in general doesn't make bad experiences good. It just takes good experiences and gives them more motion fluidity. Anyway, that's my overall thoughts. So basically, if you are a primarily single player gamer who likes to turn up graphic settings and has a very high refresh rate display, those are cases where the ×4 frame gen and the extra VRAM might make the make the 5060 Ti the better call. If you're somebody who primarily plays esports competitive games with no frame gen activated and often turns down graphic settings, well then 12 gigabytes is going to be plenty for your esports games with graphic settings turned down. And you're not going to be using the ×4 frame gen anyway in that case, in which case the 4070, having a bit more raw performance, is probably the better way to go. Last thing to consider, though, is just that the newer generation of card might have longer driver support, may or may not perform better in resale value as time goes on. Hard to quantify that and predict in the crystal ball, but those are always other factors to consider. So overall, these are similarly performing GPUs, but in raw performance, the 4070 is more powerful. Can I just say as a side note, it's pretty sad that a 5060 Ti doesn't beat a 4070 from the previous generation, like one half notch up on your performance tiers from the previous generation, and it didn't even match it, let alone beat it. That's kind of sad. But anyway, they are similar in performance, but the 4070 has more raw power, 5060 Ti 16GB has more VRAM and ×4 frame gen. These differences will appeal to different people. Hopefully we've established those, you found it useful and or interesting. And don't forget, the best deals right now are on the used market. Check out jawa.gg to look for good deals and to sell your used hardware to fund your upgrade. Don't forget about code OWEN10 for $10 off your first purchase. Use the video description link or pinned comment, and I hope all of you have an excellent day.